Hello guys, my name is Lazaro and today we're going to be doing a medium LeetCode problem. This problem is called Remove Duplicates from Sorted List 2. Given the head of a sorted linked list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. So let's look at the examples. Here we have 1, 2, 3, 3, 4, 4, 5. And since the 3s and 4s are repeated, the correct answer is going to be 1, 2, and 5. Here in the second example, it starts off with 1, 1, 1, 2, 3. The answer for this is usually 2, 3 because the ones are repeated. And what this second example tells us is that the head node could be a repeating number or a repeating node. Now down here are the constraints. Something we should notice is that the list is guaranteed to be sorted in ascending order. And with that being said, it's going to be pretty easy to return the linked list sorted as well. So now that we read the problem and we looked at the examples, let's get into the logic of how we're going to solve this question. So here I've set up an example linked list. 1, 2, 2, 3, 3, 4, 5. The answer to this is just going to be 1, 4, 5. So how are we going to solve this? Well, we're going to solve this by using two pointers. The first pointer is going to run through this whole linked list, and then if there's any repeating values, it's going to tell the second pointer to ignore those nodes. So let's try to implement that. The first pointer is going to be looking at the head, and then the second pointer is going to be looking at empty node. But that empty node points to the linked list we were passed. So it's going to look something like this. And the reason why we want the second node to point to an empty node is because, as we saw in the second example, the head node could be the repeating number. So to just combat that, or to work with that, to be safe, to make sure we get the right answer, let's start off by looking at an empty node and then compare its next value. So here, just by starting off, we know that this current node's value is not equal to its next node's value. And now, by knowing that, we know that this node could possibly not be repeating. So we know it's not repeating, where if we take this linked list and we compare it to the next of the current node we're looking at with our second pointer, which is going to be this linked list. If they are both equal to each other, we know that there are no repeating values. So we know there's only one 1. If there was multiple ones, and this pointer, for example, if there was something like this, then we will have a situation where we will start off here, and the linked list would not be equal to each other. Because in this linked list, there's only one 1, but in this one, there's 2 1s. But that's not the situation right now, and that will appear later on. But since we know that this linked lists are equal to each other, what we can do is just move both pointers. But now, here, we know that this node's current value is equal to its next node's value. If this is the case, then we know it's 100% repeating, and we can just move the pointer again. Now we get to this situation, where this node's current value is 2, but its next node's value is 3, and they're not equal to each other. So here we do the comparison again. We take this whole linked list and then compare it to the next of this node's linked list. And as you can tell, they're not equal to each other, because this has 2 2s and this one only has 1 2. The reason why this only has 1 2 is because since we knew these two were repeating because we checked this node's value and then compare it to the next node's value, since they were equal to each other, we've moved this pointer down 1. But we didn't move this one. So that tells us that this one has multiple 2's, so it's longer, and this one only has 1 2 and is shorter, so they're not equal to each other. Where they're not equal to each other, then we want to move this pointer 1 time, and then go to this second pointer and change its next value. So instead of pointing to 2, it's now going to point to 3. What this does is it removes the 2's from the linked list. And we know to point to 3 because we're basically pointing to wherever this pointer is looking at. And since it's looking at 3, that's exactly where we're going to point to. But now that we're at 3, we know that the current node's value is also equal to its next node's value. So we move it one more time. Now we get to this situation where we compare once again. So is this linked list right here equal to this linked list right here? This linked list goes, oh sorry, it should be this one right here. There we go. So this one goes 3 4 5, and then this one goes 3 3 4 5. And they're obviously not equal to each other. So that tells us that this 3 was repeating. And since it was repeating, we once again move the pointer and change the next value of this pointer. So instead of looking to 3, it now points to 4. What this does is it removes the 3 from the linked list as well. Now, this 4 5, this current node's value is not equal to its next node's value. So we compare once again. We have 4 5, and then we compare, we take where this pointer is looking at and take its next. Its next is going to be 4 5. Since they're both equal to each other, we move both. So now, this pointer is going to be pointed to 5, and then this pointer is going to be pointed to 4. Now, this pointer is at the end. So if it's at the end, all we really have to do is just compare it one more time. Since it can't look to its next value, we don't check for that. Instead, we just compare again. So what we compare is if this linked list is equal to the next of this pointer, which is just a 5. And it is. And now, since that's the case, we move both pointers one more time. Now that this pointer is out of the linked list, we have finished. And if we have kept track of where this started, since we updated all of these nodes, our answer is now going to be 1, and 1 points to 4, and then 4 points to 5. And we get the right answer. And we do this by using 2 pointers, having one run through the list, and then check whether or not a node value is repeated. And then whether or not it's repeated, it tells the other pointer to point to this node or not point to it, depending whether it's repeating or not. And that's all the logic that we're really going to need to solve this question. So let's actually write out the pseudocode of how we can solve this. So we first want a linked list with an empty node. We can do that by, I'm going to create a variable and name it answer. Let's have it initialize to a empty node, and let's have that next value of answer be equal to head. where head is the head node of the linked list we're passed. So now in this answer, that answer variable is basically represent this linked list right here. But now we want both of our pointers. We can do this by just initializing p1 to be equal to answer. So here p1 is going to be pointing at this empty node. And just in case it might be a little confusing, let me name it. Let's name that p2 is going to be answer. Now p1 is going to be looking at the head. So p1 is this pointer, and p2 is this pointer. Now what we really cared about is this pointer went through the whole list, and we only stopped when it finished the list. So that's the only pointer we really care about, depending whether or not we should stop checking the list. So we want to check wow p1. So while p1 is not on a null node, we want to run some logic. And what is that logic going to do? Well, since p1 is looking at the head, we want to check if its current node's value, if its current node's value is equal to its next node's value, then we know 100% sure that that node is going to be repeating. And let's just move it one down if that's the case. So while p1 has a next node and p1, the value of its current node is equal to the value of its next node, then we want to move p1 down one. And this is the logic for that. This is all we need. But now let's say we get to that point where they're not equal to each other. So for example, we're looking at 2 and its next node is 3. If this is the case, then we want to compare the linked list, just how we did when we were going over this problem. So here, if p2, which is looking at that null node, dot next, now since we're calling dot next, is looking at the actual linked list we got passed. It's no longer looking at the null node. So if p2.next is equal to p1, if they're equal to each other, then we know that there was no repeated values of the current node p1 is on. So if that's the case, p1 is going to be is not going to be equal to p1.next, and p2 is now going to equal to p2.next. But let's say that's not the case. Let's say that p2.next does not equal p1. Well, if that's the case, then we want to move p1 one more time. So p1, let's set that equal to p1.next. And let's set p2 equal to, let's set p2.next equal to p1. Basically what this is doing is, let's say we were at the 2 and its next node is 3. We're going to be taking this whole linked list and now we're going to be comparing it to this whole linked list. And I know it's a little bit messy, Well, that's because we row over, right? But we know they're not equal to each other. And since they're not equal to each other, what we want to do is move P1 and then set P2 dot next equal to P1. So that's why this arrow is here. And that's the logic we're doing with this if and else. So other than that, we really covered every possible scenario. And with this, it should be enough to have a linked list that has no duplicate nodes. So now all we really want to return is answer.next. And the reason we're calling answer.next is because answer, its first node, is just a 0. It's empty. And its next actually points to head. And since P1 also points to head, and P1 is changing things in head, then answer.next is going to have those updates. So that's why we return answer.next. And this is all the code we need to solve this question. So now that we did this, let's actually write this code out and see if it works. All right. So let's create answer, and let's make it equal to a no node. Here I'm going to pass it 0. The default anyways is 0. And this I'm going to be writing in Python. Now let's set the next value of answer equal to head. And then finally, let's create our 2 pointers. So P1 is going to be equal to head, and then P2 is going to be equal to answer. Now, while P1 is a node inside the linked list, and it's not a none or no, then we want to do our logic. And what logic do we want? Well, first off, if the current node of P1 has the same value of its next node, then let's just move P1 up 1. So to do that, we first have to check if P1 has a next node. And if it does, then let's check the current value of P1 and see if it's equal to P1.next, that value, which is the value of its next node. If all those conditions check, then we could move P1. Else, now we want to check if P2.next is equal to P1. Now, if they are equal to each other, then all we have to do is just update P1 and make it equal to P1.next and move P2 as well. But else, if this is not the case, then we do have to change P1, set it equal to P1.next, and change P2, what the current P2 node points to, and change that to P1. Other than that, we just have to return answer.next. So now let's submit this and run it and see if it actually works. So it's accepted here. Now let's submit. And it's also accepted here. Perfect. So hopefully you guys enjoyed this video. If you did, then please leave a thumbs up and subscribe. We send out problems like this in our Discord channel every single day for both beginners and advanced programmers, just to help them with their interview or to land a job. So if you're interested in that, then join our Discord channel or Discord server, which is linked down in the description. I also do want to say that the time complexity of this algorithm is O of n, where n is the size of the linked list, and the space complexity is O of 1, aka constant time, because we don't really have an array or a dictionary we're adding values to. So other than that, I hope you guys enjoyed the video, and I hope you guys have an amazing day. Thank you.